In this example, we're going to be calculating our Kb, our dissociation constant for our base of pyridine, if it starts with 0.125 moles per liter and its pH is 910. From here, we can calculate the pOH and then use the pOH calculated to get our hydroxide ion concentration. We have 10 to the negative 4.90. This has 2 decimal places, so that tells me that my final answer should have 2 sig digs, but in our ice table we're going to use more. So this gives me 1.26 times 10 to the negative 5, but remember that it will be 1.3 times 10 to the negative 5 when we use it in our Kb calculation to remember the 2 sig digs. Okay, now we can put in our ice table of our base in water gives me my conjugate acid plus hydroxide ions. I'm starting with 0.125. It's changing by a factor of 126 times 10 to the negative 5. And at equilibrium, we're going to have 0.1249874. On my other side, my conjugate acid and hydroxide starts with nothing. It changes by a factor of x, increase. And we already know at equilibrium that it will be 1.26 times 10 to the negative 5 for both my conjugate acid and my hydroxide ion from the calculation using the pH. Now we're going to calculate the Kb. Kb is equal to my products divided by my reactant, excluding water, squared. I have 2 of those. Put my concentration at equilibrium of my base here. And we're going to get a value of 1.3 times 10 to the negative 9. We rounded to have 2 sig digs because we had 2 sig digs from our OH. All right, so this is calculating the Kb when we have our pH given to us.